Welcome to the series. This is where we learn how to build custom AI agents with the latest large language models like OpenAI's GPT-4o, Anthropic's Claude, etc. Then Langchain, LangGraph, LangSmith, and Python. This is the 6th video of the series. In this video, we'll build reflection agent orchestration. Yes, no more single agent. This will be a structure where multiple agents will work together. This is where LangGraph really shines. Here, we will do the following. First, we'll go over the reflection architecture with a diagram. Secondly, we will build and test our Twitter expert agent who will write the tweet for us. Third, we will build and test our Twitter critique agent who will revise the tweet. Fourth, we will build and visualize the graph using LangGraph. Lastly, we will run the graph and analyze the result on LangSmith. Now let's get started. Alright, so this is what we're going to build. This is a simple architecture consisting of only 2 agents. So initially the user sends a request to generate a tweet. This is our starting point, our first agent, the Twitter post generator, and we use GPT-4o to build this guy. This agent then creates some initial response or initial tweet, and that tweet ends up with this reflection agent. And this guy is the Twitter post critique, and we will use Claude Sonet 3.1 to build it. And this guy will analyze the tweet and create some critiques. We're going to call that reflection response. This response will be sent back to our generator agent. And this will go on and on until we get the product right. And how many times this is necessary to get a perfect result will depend on this reflection agent. And that's the reason we're calling it reflection agent orchestration. Now, if we leave all that to AI's hand, that may not work great for us. It could just go on and on for too long and end up crashing the whole process. Because of that, we bring in the conditional edge. Now, if you've been following this series, you know that in LangGraph, we call our agents nodes, and the way they are connected to each other, we call them edges. And we have 2 types of edges, normal linear edge, and the other one would be conditional edge. That's like a traffic cop that will redirect based on logic. And this is where we're going to add this logic right here, which is a variable called max iteration. And as this loop goes on and on, we just keep track of this revision number in a state with LangGraph and keep comparing with the max iteration. For example, let's say if we set this to 5, that means, and this loop will not go more than 5 times. And once that hits the max iteration, it's going to end the loop and send the final response to the user. And that's pretty much it for this agent orchestration. Now let's get started on the code. All right, so let's get started here. These are the libraries I just installed. As you can see, the version is 0.3.9, that's Langchain. And LangGraph would be 0.2.53. And these are the latest at the moment. And here I am loading all my API keys. As you can see, OpenAI Anthropic are right here. And the rest of the 4 are basically to set up the LangSmith tracing. And this would be our project name. So now let's go to the next step. This is something I just keep to test things out before I get started. A very simple structure and lets me know that if everything is working. So let's try it. Boom. All right, so this shows things are okay. And let's check the LangSmith. All right, look at that. It's showing up right here. The request we made and all the details are right here. Great. Now let's get back. And yes, and before we move forward, I should let you know that I actually tried to use O1 Mini and Preview. They work nicely like this in simple setup, but they are not ready to accept system prompt just yet. And without system prompt, we cannot build agents, at least not with LangChain that I know of. So I had to ditch them and go with GPT-4 and Claude. Now let's look into our reflection agent. To build this reflection agent orchestration, we're going to follow these 4 steps. First, the generate agent, then the reflection agent, and then we're going to take this agent and turn this into this graph, build the graph, visualize the graph, and then run the graph. So let's get started. All right, so to get started with generate agent, we first bring in the necessary libraries, and then let's build the generate prompt and chain. And this is what it should look like. This is going to be our Twitter expert. And initially, we're going to just bring in the chat prompt template and add a system message which will shape the nature of the agent. As you can see here, you are a Twitter expert assigned to craft outstanding tweets, blah, blah, blah. And if the user provides feedback, refine and enhance your previous attempts accordingly. Now, this is the most important line in here. With this line, we are preparing our generate Twitter expert so that it is now ready to accept critiques from other sources, and based on that, it's going to go ahead and recreate or improve upon its previous product, right? So this is how it knows. And then we put in the placeholder variable messages. This is where it's going to store all the revisions. And now we create the OpenAI LLM using GPT-4 Mini, temperature 0.7, and using LCEL, which is Langchain expression language, we generate our chain. Generate prompt, pipe, OpenLLM. And this is what the generate chain looks like, which is a runnable sequence. Look at this hideous thing. We don't really need to know any much details about this, but I'm just showing you for the sake of learning. This is what a runnable sequence look like. Few things to notice here, that that it's actually ready with our input variable messages, and it's using the Python typing class and annotate methods to create the data structure. And right here, our system prompt, which actually shapes the nature of this agent. And right here, GPT-4 Mini is our model. And that said, let's go to the next step, testing generate chain. All right, so let's test the chain. And here I have a variable, empty variable tweet. You'll know why later. And here's the request. And we're sending the human message. The content would be USA election 2024. Basically, this is going to be our topic for generating tweets. And now the result variable will take in generate underscore chain dot invoke. Remember, I said that's a runnable sequence, and this is why. We get to invoke it, and we're still using this messages variable. It actually holds all the message data as we progress, and we're sending this request as messages. Now let's print it. Let's see. And boom, here's a tweet. So this is our initial response or initial tweet by our generate chain. And remember, we are simply testing it right now. We're testing it so that we can confidently use them later when we build the agent and add them to the graph, right? So next is step 2. All right, so step 2 consists of 2 parts: creating reflection prompt and chain, and testing the reflection chain. So let's start here. So this is our Twitter critique agent. At this point, we're just going to create the chain, but this time we're bringing in chat Anthropic so that we can build our model with Claude 3.5 Sonnet. But before that, let's look at our system message. This is the one which shapes our agent into a Twitter critic. For example, let's see, you are a Twitter influencer known for your engaging content and sharp insights. review and critique the user's tweet, provide constructive feedback, focusing on enhancing blah, 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 right? So this is what turned this agent into Twitter critic. So as usual, as a message placeholder, we're sending messages. Now remember, this one actually has the message from our past one also, the one we just created. And here we have our model, and once again using LCEL or Langchain expression language, we create our reflect chain, and let's run it. It's pretty much the same thing as before. We clear it out. Now let's go test it. Now here we declare a reflection variable empty, and this time we are invoking that reflect chain, this guy here, with the dot stream, which will stream out the results instead of one time when we do invoke, right? And the reason being, we're expecting more output here, so we put it in a loop chunk in reflect chain dot stream so that it generates step by step, and then we print our content in chunks. So let's see what it's doing. There you go. See, little by little, a pretty big critique comes up. Now remember, we are still just testing it, even though we sent tweet, which is an empty variable, but it still managed to give us some critique, right? Lack of specificity, missing hook, blah, blah, blah. All these are based on this request item here, as we mentioned right here. Only thing it got is the USA election 2024. Based on that, it generated the critique. It did not really have this guy here. Once again, we're just testing, but once we manage to put all of them in the graph, create the agent nodes, this is what it will receive. Now we're simply testing. So let's go back and review it. So we're doing all that just so that we can confidently use these chains when we build our graph, which is this next step here. Okay, so initially we bring in list and sequence from the typing Python class for structuring our data, and the end node and the message graph from LangGraph. Now notice this is message graph. Normally we use state graph. In this case, we will only be dealing with text-based messages, so we don't really need state graph, with which we can use multiple different type of data structure. But here we don't need all that. We just need the strings. All right, so this is where we define and create our graph. Initially, I'm bringing in the base message class from Langchain core messages, and this is where for the first time, we actually create our agent nodes. So here you can see the generation node, and we are putting state as an argument, which is the data type would be a sequence extending the base message class from Langchain core message. And here we are simply returning that generate chain dot invoke messages as the variable, state variable. And this is the one we just tested up there. And this is going to be our simple generate agent node. Now this is the one which is more interesting. So let's go up a little. This is going to be our reflection agent node. Here we are sending messages as an argument, and the type would be once again the sequence extending the base message class, and it will return a list extending a base message class from Langchain. And this is the most interesting part. Here we are rewiring the message architecture. As you can see here, as AI message, we are putting human message and human as AI message. And here we are using a translated variable to reorganize everything. What we are doing is basically taking the first human message out and making it static, because first human message would be the actual human instruction, right? And after that, the conversation will go on between agent to agent. So just by switching these messages, we're going to fool this reflection agent into thinking that the initial tweet message is coming from a human. This is where we're getting the swapping done. Just to explain this a little better, let's go to this demonstration here. So here, the initial message structure, let's just say, it looks like this. Human message, write a tweet about AI. This will be the first and original human message. And then everything should be like AI message. AI is revolutionizing industries, right? So let's say this is the tweet generated by the AI. And then the human message would be, make it more engaging. This human message is basically a critique generated by an AI, right? So if this is the structure, what we're doing here is we're switching human and AI message and then translating it by separating this message 0, which is this guy, separating it as a static context, because now whenever we send this translated structure to any agent, they will always have this static message, which is the main human message, so that they never lose the context of the target objective, which is write a tweet about AI, right? And then all these are going to be variables. Now here, once we swap it out, this is the structure is going to look like. First human message, the original message, and then human message, AI is revolutionizing industries, and then our reflection agent will create a revision or a critique based on this guy right here. So from this point on, whatever is received from our generate agent is going to be the human message, and whatever our reflection agent would generate will be the AI message. This is exactly what's happening through this code. Basically, we are fooling the reflection agent into thinking these messages are coming from another human. So let's go back, and then we invoke that reflect chain with that translated structure and what we get back. And at this point, we just send it back as a human message. So basically, whatever result we get will be the critique from our reflection agent in here, which was the AI message, right? But once we get the result, we're sending it back as another human message, because now what's going to happen is this guy, as in our structure right here, now we'll be sending this message back to generate agent. So when generate agent receives that reflection response as human message, this guy also will be fooled into thinking these critiques are coming from another human. Thus, it's going to go ahead and do its work, regenerate everything and send the response back. And in here, we're going to change those messages, reverse it. So now this guy will think, oh, it's coming from another human, and it's going to go ahead and do its thing and send back. And that's how it will go on. All right, so now that we have our generate node and reflection node, let's build the graph finally. Now we're going to bring in the message graph to create our builder and add the nodes. Generate is our node name, and the function name is generate node. And builder add node, reflect is our reflection node name, and then reflection node is the function that we just saw here. So now our agents are added to the graph, but remember, they're not connected yet. So at this point, we just mention a starting point, because generate will be our starting point, as we saw here. We're just mentioning that this guy is the starting point. That said, now for the first time, we define our conditional edge. It's a very simple logic. We're pretty much counting the number of messages in the state variable, which is basically this guy right here, message state. And everything is going to be stored inside these messages. So this is the one we count to find out how many iterations we have. And we're going to be comparing with this max iteration, which is set to 5. So if it reaches that 5, it's going to return end. Go to the end node, thus breaking the loop. Otherwise, it will keep returning the reflect message, basically the result of this node, thus keeping the loop going. And last but not least, we're going to go ahead and connect those agents. First one with the conditional edge, generate, and should continue is this function, which is this conditional edge right here. This way, generate agent is connecting to reflect agent using this conditional logic where max iteration is declared. And then a normal edge, builder.addEdge, reflect to generate, which is this guy right here, completing the loop. Finally, we build our graph. Builder.compile. So let's run that. Okay, successfully ran. Now let's go view our graph. We're simply using python.display library to display our graph. Inside that image function, we are sending graph.getGraph and using .draw marmaid png to create a PNG file, a PNG image of our current graph. So let's run it. So this is what we just created. Starting point, generate, creates the loop with the reflect, and then once the max iteration is reached, or the reflect agent decides that we already have our perfect product, it just breaks the loop, goes to the end, thus sends the final response to our user. All right, now let's go the final stage. Here we're going to run the graph. All right, so we are ready to run our graph. So we are declaring this input variable, human message, and the content should be generate a tweet about FIFA World Cup 2026. And now response, we are invoking the graph with inputs, and we're going to display it step by step by drawing a line in between so that we can see the difference between two types of responses, which is a generated Twitter versus a critique. So let's do this, and it's going to take us some time because it's doing a lot of stuff behind the scenes. It's going through all these steps, doing the loops, and then doing a whole bunch of back and forth. So let's give it some time. All right, look at that. So what we have here. So first, that is the static context message. Remember, we separated it out because that's the main user input. Generated tweet about FIFA World Cup, and this is the initial response or initial tweet, and this is the initial critique, and then it was generated again. It went once again, second time in the loop, some excellent revision, blah blah blah. It's and then it's going ahead and giving some more pointers, and finally, after 2 rounds, the reflect agent decided that this is perfect. This is good enough. And just to conclude, let's go back to our LangSmith. Boom, there you go. This is the one we just created. So let's go in there. It has all the steps, generate the initial human request, and then the first generated tweet, and then look, this is the human. This thing's, it actually human critique, because we converted into human message. We returned the human message. Next, this is the second tweet, second revision, and this is the final output, and this is the one we're going to send to our user finally. With that, we just successfully built our reflection agent orchestration using Langchain, LangGraph, and Python, and tested the result with LangSmith. Next time, I'm going to bring in reflexion agent orchestration. Stay tuned, like and subscribe. Until next time, thanks for watching.